Hello and welcome to this MagiCAD for Revit MEP webinar. This is the provision for voids tool, also known as builders work or builders work openings tool for Revit. Within Revit itself, you have the MagiCAD common toolbar at the top, and as part of that is the provision for voids tool here. If you click on this, you'll see a option for manual and an option for automatic provisions. Now what this is enabling you to do is create a manual size and type of opening, or a request for an opening as it is, and you can choose whether it's a circular, rectangular, horizontal, vertical, that's either a wall or a slab, and you can choose the dimensions of the builder's work opening there and any kind of offset height. In this case I'm going to create one that cuts a hole in a slab, so I'm going to put it offset slightly below the floor so it cuts through the slab, because my floor level is the top of the slab, so you obviously need a minus offset to cater for the slab thickness in this instance to cut through it. You can also select that it's going to be for ventilation and plumbing, so you can tag that and have that data associated with it. This manual type of builder's work opening is useful for anywhere where you want to create obviously an opening, which is not going to be used in the MEP services to determine the location and size of it. It's also very useful for early stage like concept design, where you're doing space claiming of plant and service routes, and also builders work openings, so you might have big riser slots or big holes in plant room walls, or main incoming services through shear walls and things like that. So what you need to have is a means of manual provision of voids, which is what this is. So you can place these in your project quite early on, get the space and the coordination of them agreed, and then at a later stage when the services go in, you can rerun the tool automatically, and hopefully the void will be created in the same place at the similar sort of size that you requested originally. So if I just press OK on here, you can see that I can place this sort of rectangular provision for an opening anywhere in the project. So you can just click in here, click in there, it doesn't matter in this particular example. So I'll just select it into there like so, and just plonk that in there, and you'll see that we now have this void created in here, and that's actually not true. It's the request for a void. So the MEP engineer is creating a request which needs to be agreed with the architect and structural engineer later, and we can see that process as the webinar continues. Of course, as I said, that's great for claiming spaces in risers and shear walls and doing early stage design. But if you get to this point in design, like stage 4A in the REBA stages, which is like detailed design, you may want to use the automatic function, which is where the real-time saving comes in. And to use this, you just click automatic, and then you have options to select certain objects to create holes for, the entire view, which will, anything that's visible in this view will be used to create openings if it meets the criteria. If it's not in the view, so this view is ventilation, if it's not in the view like cable tray, then it won't use that. Or you can do selected levels at once and do the whole building or some levels at a time. So it's quite flexible how you want to create these openings. But before I do that, I just want to show you how this data set works and the options for the void. So if I go into here, you'll see that we have an offset around ventilation services here. You can choose piping and electrical offsets as well. You can choose individual offsets for these different service types and different object shapes. This enables you to give different criteria, for say cable tray to pipe to duct and things like that, which, as you know, will be likely required on site to have different height offsets off cable tray. That could be, say, electrical, that could be this H3 dimension could be 150 or something like that to be able to get access into the tray at the top. So there's various ways of configuring the different services, and it will automatically detect if it's vent, pipe or electrical based on the category of the object passing through the architectural or structural element that's been cut. You can put extra offsets around fire dampers. It will detect automatically you've got a fire damper or a flow damper in the wall, and then give you an automatic offset extra above so the ventilation is say 50 mil here, that'll be an extra 50, so that'll be 100 mil. And also on the fire damper itself, you can select a parameter which will override this default. So if you had one single type of parameter where you had for instance a large actuator on the side of it or top of it, you could give a dimension, and it'll override this default and put the type parameter for that fire damper of whatever figure you give it. It will cut that hole. When you have multiple services, like you might want to have a slot going through a wall, so here you can see that it's 100 millimeters is H4 dimension, so you can see here if the two builder's work openings were to encroach on each other less than 100 millimeters, it would basically cut a slot around this rather than having two individual holes next to each other. So you can control that size by changing that value in there, and it will create multiple. So obviously you have like 6 pipes in a row, and all of them were, the builder's work hole would have been between 0 and 100 millimeters between them. Then in this case it would have cut a big slot for all 6 pipes there. Minimum diameter of circular voids, that means you can have a minimum size for any circular hole, like a micro bore pipe at 10 millimeters. You can still put a minimum of 40 millimeters in there, let's say, for that pipe size. Maximum diameter for circular voids, you could put that at 250, because that's to do with core drilling, and generally you can't core drill much more than that on the site, or you break a wall out with a rectangular shape, or break some blocks out and put a lintel over it. So that's how that is controlling the shape of the opening. So even if it's circular like a duct or a pipe, it will still put a rectangular, anything above that diameter there. And that isn't the diameter of the pipe, by the way, that's the diameter of the void. So it manages what the software does, it reads the size of the object, reads the size of the opening that will be required, and then applies these rules to the opening, so we don't have to think about the actual size of the services of the openings yourself. Rounding step, that's to help you create builder's work openings within 25 or 50 mil rounding steps. Otherwise you'll end up with random, like 384 times 267 and etc all through your project, which no one really wants. So it's sensible to have a good rounded figure for them. And similarly for rounding limit, if you just exceed a certain dimension, you can round it down if you want to as well, using that figure. And if your contract says that you're a consultant and you're not providing any builder's work, anything under 100 mil will be dealt with on site, then put 100 millimeters in there, and that won't create any builder's work openings that are anything that's smaller than 100 mil. And you can change your text in here as well to determine what the actual tag will be labeled as well when it creates the openings. So just press OK there if you're happy with that. Press close. Back to the void tool, press automatic. And this time I'm going to look at the current view, so I'll just press OK. And what it does, it now reads the project for interferences between MEP services and the architectural or structural elements. And you can see here we've had a warning for a provision colliding. So what's happened here is I've put that previous one in into the floor slab, but it's also detected that we need openings in here which haven't been created yet. So what's quite handy is we've now received a warning. So if this was at stage 2 and we had this void requested and I forgot about it and then ran it again, you can see there that it's trying to put some extra holes in for this riser, but you get a warning about it, so it's not just going to do it randomly in the background so you wouldn't know about it. So it gives you the choice of how you want to deal with that. In this case, I think I want to remove these additional ones and keep my original riser position in there. But everywhere else it's put the The void's in as expected with the automatic detection tools. And let's go to a 3D view here. You should be able to see the actual requests for the openings themselves. What they look like is like cylinders or rectangular openings. So there's like a family created into the architectural element there, and you can see that it's put the offsets in there. You can see how that works. You can see here you've got a square or rectangular hole request, even though it's a circular object, because clearly that exceeds the limit of 250 we put into the settings previously. There's a square one there anyway. You can see it's missed a cable tray out because that wasn't visible in this view, etc., etc. It hasn't put the void in there because the size of the void would be below the required minimum size for the void that we put into the data set. So you can see how all that goes together in that manner. So you can see here there's a bunch of pipes that weren't visible in that view. If you want to create a builder's work opening for these separately in this view here, if we go back to automatic, this time I'll do select objects, press OK, and this time I'll just create some opening for this bank of pipe work here, for example, which is additional to the ventilation one. Press OK, finish. And you can see that it's created the opening in the wall there for the two that are penetrating it. The other two, so the other pipes are selected, weren't penetrating through the wall. But you can see what it's done there. It's put the multiple services into a one single opening there for the services that are penetrating that wall there. So that's how that's designed to work. So you can see you can do a combination of automatic provisions for the view that you're in. In the case of us, it was previously it was ventilation, and you go to a different view and you can create different openings in different areas just in case you want to concentrate on one bespoke type of area or service. So that's how you create the voids, and that's a very sort of straightforward way of creating the builder's work openings. Once you've done that, we can now save this model, and then effectively we're going to share it with the architect. So I'm going to close the model down, and I'm going to become the architect now. So I'm going to open the architectural model as if I'm the architect, and I've received the new MEP model linked into my my architectural model. And what we'll be able to do then is review the request for the openings in my architectural model as an architect effectively. And then once I've done that, I'll be able to review them, and then if I am satisfied with them, I can then provide the actual opening themselves. So if I just expand this out a bit here so you can see what's happening. So you can see in this view here, we've now linked in the MEP services into the architectural model, and you can see the request for the openings there. You can see all there, and the manual one, the riser, you can see there's the riser in there, which I requested as well. That was the manual one. So you can sort of review how all these are formed in there. But instead of going through manually like so, we provide a free add-in, and anyone can have this. It's not a MagiCAD customer. Any architect or structural engineer can obtain this add-in. It's on our website, and you can MEP engineer can send it through to the other project team members. They can install it, and it just gets added into the add-in sections of the ribbon. And when you click on that, it will scan the project for the openings that have been requested by MEP engineers, and then if you want to, you can just click show. So if we'll have a look at this one here, just click show, and it'll jump to the exact location of that void. You can also see it in a little 3D preview in here as well, and you can see data about the void and what's anything in the area of it, the height of it, whatever it is. So you can, if you want to determine something about it, which well, we know it's the riser in there, and then the architect can do that for every single opening as they wish. Just keep going around and reviewing it. And if they're happy with it, they can then click on here and the report, click accepted, and then click accepted. If they're not happy with it, they can click rejected and put a comment in saying something like move left or something like that. And then the ones that they are happy with, they can just keep going accepted, hold down shift once you accept it as well, and then you can fill the whole bunch of them at once. And then the ones that we've accepted, if you click the create void, it will create the actual openings themselves, like so. You can do a bunch of them at a time, and it will create the actual openings where possible. And you can see that the actual openings get an ID as well as the provision for it, so they're now linked. The ones that have been rejected do not get created, so that's left blank. And then we can just save this as a report, so we've got a record of this builder's work process, so we can just call it builder's work in connection with report version 1, and save that. Then press OK, and you can see what's happened now is it's actually cut the holes where we've actually requested it. So in the architectural model, they can now review. You can see there's actually cut a hole in the wall, so that's quite nice. So you can see exactly where your services and architecture are coordinated. So you can see underneath the wall that it's now got the riser hole cut through there. So I'll just make these changes and save them, and then go back into the MEP model. So I've now received the architectural model update with the provision for builders work now physically cut into holes where accepted, and then left blank where rejected for further review. And I can come into my MEP model now, and I'll go into the 3D view, for instance, and I will then be able to zoom in and have a look at any of my builders work openings, and you can see now in my model they're all open, they've been cut, so you can physically see in there, look, there's a hole. And then if I look down there, there's the riser going to basement level there. So you've got a combination there of automatic builders work openings and manual builders work openings, risers. There's the bank of when I have multiple services going through and it's connected them as one, so you can see it's cut the hole in there as well. So everything's done everything in the model as expected. I can also use that free add-in myself as a MEP engineer by looking at this report, opening the report from the architect. You can now see all the detail. There's one that's been rejected. If I click show, it will zoom to that location, and I can now see that it's actually not being cut in the wall because it's been rejected, and the architect says move it left. So apparently it's too near to the wall or whatever it is. So all I have to do is like shift the void and the duct left, so you can see there, just moved it left a little bit. And then if I went back to the architect now and said how about now, they'd be able to review that again. If they're happy with it, they follow the same process, create the void, send it back, and then that will become a physical hole in the model. So that's provision for voids. So that's a very brief overview of the process, but you can see how that should really expedite your creation of and the actual management of the data and the sharing of the data in a sort of BIM environment where everything's contained in a model, so there's no more marking up of plans and scanning and red pens and back and to, and you should be able to do it all through a Revit model. And then on top of that, as an MEP engineer, you might have a deliverable which is to actually produce builders work drawings as well as the 3D coordinated model. That's not a problem because you just come into here, create a builders work model. You can see here we've got some builders work already created, and if I want to go and tag these builders work, I can just click on there, and you can see that it just tags it automatically with a diameter and a offset off the ground there. So you can just keep doing that for all the builders work as you wish, or you could tag them with a number. So you can see there it's just putting all the dimensions in. So you can very quickly create a builders work drawing which is a deliverable. So it's saving you a lot of time, where traditionally you have to translate all your markups and conversations with architects and structural engineers and put it into a CAD drawing and obviously try and coordinate that together. And there's obviously lots of scope for mistakes and things like that. So you should find that actually this makes the whole process a lot quicker and easier and more traceable. And you can see there's like a builder's work drawing on the sheet, and you can obviously schedule those ones out as well like that. And then as things update, clearly these will update on the sheet as well. So if I move that builder's work opening to the left, and the whole tag, everything, the actual indicator on here would actually, the symbol would move as well. So I hope that's been of use. That is the builder's work tool.